Hello, Precalculus student. This video is for chapter 1.7, Inverse Function, part 1. We're going to look at what is the meaning of inverse function, what's properties of inverse function, and most importantly, if someone gives you a function, find the inverse function. So, what is the inverse function? If I have a function that is one-to-one, so remember, inverse function exists only if it is one-to-one. What happened is one-to-one, I would have x and I apply f, the function f rule, and I would have f of x, which is equal to y, right? Inverse function is a function that maps y back to x. Because what happened is for every x, you have a unique y. They never repeat. So if you have one y, it always go back to the same x. We call it one-to-one function. So only one-to-one function would have an inverse. And the symbol of the inverse is f -1, like that. So it seems like a negative power, but it is not the reciprocal. F to the power -1, this symbol, we call it F inverse, is a name. So it's kind of like a symbol. So we just name it this way to relate the fact that these two are related in that the original function map x to y, the inverse function maps y to x. And because of that, you can see, well, if I do a composition, that means I start off with x, I go to y, and then I go to f of -1, I end up getting back to x. So f composite with f inverse is exactly bring you back to x. And if you start off with f inverse first, and then go to f, that means you go like this, and then go back, you, well, yeah, you go you go from a y, go to x first, and then you go back, you still get back to y. So no matter how you composite f and f inverse, you're going to get back to x. So this is the only case where f, the position of the composition doesn't matter. Usually f of g and g of f are different, but if they're inverse, then they both go back to x. And also because of the nature, so for f, we have domain of f, we map it to the range of f, but the inverse map the output y back to x. So to the inverse function, the range of f is actually the domain of f inverse. And the domain of the original function f is the range of f inverse. Okay, so we can have this like kind of properties where the domain of the f of x is the range of the f inverse, and the range of f of x is the domain of f inverse. And also you can see when x goes to y, using the f function, this is very small. Let's go to y using the f function. Y would go back to x using the inverse function. So in the graph of the f inverse, there is a point y comma x. In the original graph, we have x comma y, but this is the input to the f inverse function, and that is x, but the value itself is y comma x. So anytime you have a point of, like, say 1, 4, that's on the original function, then 4, 1 is in the inverse. So this is another properties, so that we have a few properties. So this one, this one, this one. And also because of that, the fourth one is f and f inverse are symmetrical about the line y equal to x. Just imagine anytime you have a function, for example, this is f, and have all these a, b, b, c, c, d, whatever. But then on the other side, if you are to graph the inverse, it would be like this, right? Oh, it's not very good. Like that. So this would be switching the x and y, switching the x and y. So they are the two functions. This is f inverse. It is symmetrical over the y equal to x. So you can treat the y equal to x as sort of like a mirror. I may as well. I just want to redraw it because it looks very ugly. So this look like a mirror over the point y equal to x. Just imagine if you have a point 1, 1, 2, 2, the inverse will also have 1, 1, 2, 2. So if your original function is like this, I want to change the color. So like this, the inverse function, if this is f, the inverse function will be like this, right? Because this point corresponds to this point having x and y switch. And remember, the notation of f inverse does not mean that it's a reciprocal. This is just a symbol. It's a name called f inverse. We don't even call f to the power -1. We don't treat it as a power. It's just a name. So practice doing those properties of the inverse function. So if I have 2.54 and x5 on f of x, what point would be on the inverse? Well, 4, 5 would be, and also xy, yx, 5, 8 would be, right? And then here we have a table of the f of x, 2, 4, 5, 6, x, 1. So what is the table for f inverse? So it's very easy. I just switch the x and y value. I still call it x. 4, 6, 1, and 2, 5, 8. So instead of 2, 4, in the inverse, I have 4, 2. Because in the original function, we do map 2 to 4. The inverse, go back, right? We map 4 back to 2. So you have 4 mapped to 2. Example 3, if the domain of the original function is from -infinity to infinity and the range is -infinity to 0, what is the domain and range of the inverse? So domain and range is a switch, right? So the domain now become the inverse, become the range, and then the range of the inverse function is the original domain, like that. So this is properties of inverse function. Let's do the let's do another video that talks about how to find an inverse if I have an inverse function formula.